Hello. I'd like to do a couple demonstrations for you tonight. The first one is going to be pulling the cart, and we're going to show the agent and the pictorial representation of this motion. So let me just go back to our slideshow for just a second. I'm going to bring up a slide here, and force vectors. So in this first image, we're going to show a woman um, pulling on a box. So here she is, and we want to identify the object, and we want to identify the agent. So the pictorial representation here is the box. It's a very heavy box, evidently. The woman is pulling on it, and the rope is the agent. The object which the force is acting on is the box, and the force that she is applying is called a tension. So we can represent this as this diagram here, or we can simplify things, which is probably a good idea for us, to something a little more simple. We'll represent the box as a particle, and the tension of the rope is the force acting on the box. Now, you'll notice that the woman is not included in this. This is actually a minor issue because of the fact that of Newton's third law. There is an interaction going on. The woman is pulling on the rope is pulling on the box, and the box is in motion. So again, we have the pictorial representation, at least for now. We're going to stick with this pictorial representation, try and keep things as simple as possible. What are we acting on? We're acting on the box. So let me just put a pen here. We're acting on the box. The agent is the rope that is exerting a force on the box. The woman is going to be excluded for the moment, but technically the woman and the box and the rope are a system. So let's go ahead and demonstrate this. So I'm going to get out of the show. So I'm going to demonstrate this again with the dynamics cart, and as you can see, I have a rope attached to my force sensor, which is attached to the cart, and I'm going to exert a force on it, and we're going to record some data to take a look and see what's happening. So I'll go ahead and click record and pull on the rope and the box, and you can see that there is a force acting. Okay, that's good enough. Here's the acceleration in green. Here is the force. Now it's not exactly perfectly steady, but we can consider just the average force. So I'll scroll over this, and this gives me a force. I'll go ahead and do the statistics on it. The force I exerted on the box on the cart is 0.299, so it's 0.3 newtons. The acceleration of the cart, as you can also see, so I'll just scroll over that. And yes, it's very jaggy, but we can get on the average sorry about this. So here I have the acceleration. The acceleration is here, and I can go ahead and measure that, and I'll just do a statistics on it since it's all wiggly, and you can see that the acceleration mean is 0.01396. Let's call it 0.014 to keep things simple. Now, another demonstration, and I will save this data. We'll use it later. So I'll store it, and I'm going to turn it off. I'm going to hide that data set. And I'm now going to do another demonstration. Let me bring back PowerPoint for just a second. The other force that we can consider is a long-range force that is gravity. Now, gravity depends upon the mass of the object, and it depends upon the acceleration due to gravity, g, which we know is 9.81 meters per second squared. So let's go ahead and take a look at that. I'm going to end my show right now, and what I'm going to do is I'm going to pick this cart up by the rope, and we're going to go ahead and do that, and let's take a look and see what happens here. I'm going to gather it up, and I'm going to click record. There we go, and here is the cart being lifted up. So now that's done, I'll put my cart back down. There we go. And let's take a look at the force. Well, first of all, here is the acceleration. And you can see this is the jerky part. We're not going to take that into account. What we do, because this is where I was picking it up from here to here, I would say, when it got stable. And as you saw, it wiggled around a little bit. I don't want that data. So I am going to select this data here for my acceleration data, and I'm going to go ahead and get statistics on it. And you can see that the acceleration is 9.544. Okay, let's take a look at the force that's acting on this. And I'll do another data analysis on that. This force is 7.85. Now, the agent was again the rope, me pulling on the rope, picking the device up. The object was the device, that is this guy. The agent was the rope. Now, I am in the picture, I will be in the picture later on because the rope and I and the device are all part of a system. So you can again represent this, and I'll just pull my show back up. Actually, let me bring it over here. So you can represent this as a dot. That's my cart. The force of gravity is acting downward. Now there was one other force that's acting on this, and I'll just go ahead and bring some things up so that we can see this. Here's my box. Okay, here's my cart. What's acting to pull it up? So I'll just go ahead and bring a pen up, and I claim that that is going to be this force. And once I have this dangling, these arrows should be equal. This is opposite to the weight, and I'm going to call that again tension. So there we are. That's the tension in the rope is balancing the long-range force, the force of gravity on the cart.